This is lesson 1.2, Angles and Protractors. An angle is two rays that share a common endpoint, provided that the two rays are non-collinear. Vertex is the common endpoint of the two rays of an angle. And sides, the two rays that form the angle. In our diagram below, we have angle TAP. You can see the vertex is at point A, and the two sides are rays AT and ray AP. There are many ways to name an angle. On this slide, we're going to name these two rays as many ways as possible. Let's start with the angle on the left. If we want to name the angle using 3 letters, we can do so as long as the middle letter is the vertex. So for example, we could call this angle ABC. We could also call it angle CBA. In both cases, B, the vertex, is the middle letter. Now, since this angle is a single angle by itself, and it has one vertex, we can also name it using the vertex, angle B. Or we could name it with a number, angle 1. Looking at the angle on the right, let's name it as many ways as possible. Using 3 letters, we could call it angle DFE or angle EFD. Using just the vertex, we could call it angle F, or we could name it with the number angle 2. The measure of an angle is the smallest amount of rotation from one ray to another. Degrees are the units used to measure angles. And the reflex measure of an angle is the largest amount of rotation between two rays. In the diagram below, we have angle GPS. You can see that the measure of the angle is 136 degrees because that's the smallest amount of rotation from ray PG to ray PS. The reflex measure of the angle is 224 degrees because that's the largest amount of rotation between ray PG and ray PS. Now combined, the measure of the angle and the reflex measure of the angle will always add up to 360 degrees, making a full circle. Angles and protractors. I'm sure many of you have used a protractor before, but let's review how this is done. In the diagram, you can see the red angle. Step 1 of measuring an angle with a protractor is to place the center mark of the protractor on the vertex of the angle. You can see this happening right here. Step 2 is to line up the 0 mark with one side of the angle. Now on a protractor, there are 2 0 marks. There's one here and one here. You may choose to use either 0 mark, but if you start from this 0 mark, make sure you measure using these numbers. If you choose to start with this 0 mark, make sure you use these numbers to measure the angle. Step 3, read the measure on the protractor. So since we started from this 0 mark, and clearly the red angle is less than 90 degrees, we will measure the angle using these numbers, and we will come up with an angle measure of about 34 degrees. Let's do a little practice here. I'm going to pull up my protractor, and I'm going to measure angle 1. I'm going to start by putting the center mark of my protractor on the vertex. Then I'm going to rotate the protractor so that my 0 mark is on one of the rays of the angle. And now I'm going to read the measure of the angle. In this case, approximately 16 degrees. Let's go to angle 2. Put my center mark on the vertex. I'm going to use this 0 mark now. And now I'm going to measure the angle to be approximately 164 degrees. And finally, angle 3. Put the 0 mark of my protractor, or excuse me, the center mark of my protractor on the vertex. There we go. And put the 0 mark on one of the rays. Looks pretty good. And we can see that this angle comes out to be about 92 degrees. Now, when measuring with a protractor, there's always going to be a little bit of approximating. So we're being introduced to the symbol that means approximately equal to. And you can see down below, there's the symbol also being used in each of the angle measures. The measure of angle 1 is approximately 16 degrees. Measure of angle 2 was approximately 164 degrees. And the measure of angle 3 was approximately 92 degrees. Now, just in case it's a little bit hard for you to read that approximately equal to sign, there's the symbol right there. Congruent angles are two angles that are congruent if and only if they have equal measure. Use identical markings to show that two angles are congruent. So down below, we can see that angle DOG is congruent to angle CAT, right? And the measure of angle DOG is equal to the measure of angle CAT. Keep in mind, as we learned in the previous lesson, figures are congruent, measures are equal. Now, how do we show a viewer, somebody looking at two angles, that the angles are congruent? Well, we use identical markings, very similar to how we showed that line segments were congruent. You can see in angle DOG, we've put one tick mark in that angle. We use kind of a little curve, and then we put a tick mark on it. And angle CAT has the identical marking. This shows a viewer that the two angles are congruent. Now, if we had a second set of congruent angles that were not congruent to these two angles, we would put two tick marks inside of the angles. And now we're going to finish up with angle bisector. A ray that contains the vertex of the angle and divides the angle into two congruent angles. Here we have angle BCA. It is being bisected by ray CD, and we know that because of the identical markings. The markings are telling us that angle BCD is congruent to angle ACD. Well, since those two angles are congruent, that means that CD, ray CD, is the angle bisector.